Hello, my name is Dermot O'Connor and I'm going to be presenting the ICT Skills 2 module on your course. So you might remember I spoke to you before Christmas where I gave you a kind of an outline or context for this module. And what I said back then was that it's essentially kind of a natural continuation from the enterprise web material that you've been covering over the last number of months, where I will be focused on just the client side. In that module, towards the back end of it, as far as I'm aware, you looked at a technology called Aurelia. So I'm going to be focused on that whole kind of client-side single-page app space. But instead of Aurelia, we're going to be looking at a framework called React. So prerequisites for my module would really just be the kind of web foundation technologies like JavaScript, HTML, CSS, just be comfortable with all of those. Have an understanding of the role of the DOM in the browser. And aside from that, you're good to go. It's not really important that you have experience of using Aurelia. It's beneficial, obviously, but not necessary. In terms of what software you need to have installed for my module, you have them all already installed, really. It's going to be Node, NPM. I also use Git quite a lot in the labs. I'm pretty sure you've been using that up to now. The other thing that might be slightly different is I use VS Code as my editor. It's not mandatory that you use it as well, although I would encourage you to maybe get familiar with it because it is quite popular in the industry. As far as I'm aware, you would have been using WebStorm up to now, and WebStorm is great as well. But you might just install VS Code anyway on your desktops, and if you like it, continue to use it. If you don't, there's no problem. Just flip back to WebStorm or whatever IDE is your choice. Now, the last thing, I don't really like talking about assessments this early in the game, but people always want to know about assessments. So the assessment side of this module is broken up to two parts, and it's kind of a 40-60 split. 40% will be going for the labs. Now, I won't be requiring you to be submitting labs on any kind of a weekly basis. That wouldn't be on really. What I will ask you to do is to submit the labs at the very end. I can talk a little bit more about that when we get into it. Essentially, the labs that you'll be doing for me will involve rolling out a React app from week to week. So you're kind of building up from week to week this React app. And at the very end, then you have a complete React app. And I will ask you just to submit that lab work in one unit at the very end. So that's worth 40%. The other 60% then is for a React application that you can develop yourself for a context of your own choosing. And again, I can talk a little bit more about that once we get into the nuts and bolts of the module. So that's it in terms of my introduction. If you want to, the slides that I went through last Christmas are up on the website for this module. If you want to just flick through them just to kind of refresh yourself, go ahead and do that. So let's get going with the very first lecture. Okay, so what I'm showing you here now is the website associated with this module. Now, because this video is pre-recorded, the website might be slightly more populated when you get to actually watch this video. So just to make sure that for lecture number 1, you go into this card here. So if I click on that, you can see that there are 2 labs associated with this week's lecture. And there's also an archive accompanying the slides. Ordinarily, there should be an image here, but it's not appearing for some reason, but that's okay. So the slides are over here, and I've already loaded the slides into PowerPoint. So I'm going to flip over there and talk my way through them. Now, from the title, you can tell that we're kind of going to get straight into it, really. And my agenda for today's lecture, is as follows. going to spend just a little bit of time talking about the background, not a whole lot of time on that though. Then I'll introduce you to JSX, which is a syntax that essentially allows us to mix HTML and JavaScript in the one kind of physical file, which was something that was unique at the time when React came out. And they'll introduce you to one of the two tools that we're going to be using to develop React code, a tool called Storybook. And the last item on the list there, turns out that when we develop a React app, we develop what are called components. So the component is the kind of unit of composition. It's a bit like a class, I suppose, in the Java world. So what React is it's a library or framework for building dynamic web user interfaces. By dynamic, we simply mean that when the user interacts with the web-based user interface, the interaction may cause the user interface to change as a result, hence it's dynamic. A more kind of technical term would be to say that React is a single page app technology, and you're familiar with that term from enterprise web. Now, like a lot of tools and technologies that we use as software developers, React actually began life as an in-house project in Instagram. This is before Instagram was acquired by Facebook. When Facebook did acquire Instagram, and they kind of got their hands on this React framework, they actually open sourced it, and that was around 2012. So that's how it came to light, really, for the rest of the community. Now, we could have nerdy discussions as to whether React is classified as a framework or a library. I'm not going to get into that discussion, but some people get hot and heavy about that, but either way. So React is a single page app technology owned by Facebook, I suppose, but it's open sourced. Now, when React came out, it kind of set itself apart from all of the other single page app frameworks that existed at the time. React was by no means the first single page app technology. So you may have heard of Angular or Ember or Backbone. These all kind of predated React. But the React framework was different from all of those. One way that it was different was it didn't decide to use the model view controller pattern. What the model view controller pattern, which you've already heard of, does is it kind of forces the developer to break up their code into the model part and the view part and the controller part. And all of the other single page app frameworks that existed, this is back around 2012 now, that existed at the time, they all required you to break up your code into these different aspects, MVC. But the React design team purposefully decided that they weren't going to actually follow that that approach. They decided that they were going to focus completely on the V part of MVC. So in a way, you could say that React is more restricted than all of the other frameworks, arguably. Either way, it was a conscious decision on their part. That's the first point. And secondly, all of the other frameworks, single page app frameworks that existed at the time, in terms of the V part of those frameworks, they all followed a templating style. And the React designers also decided that they weren't going to follow that approach. They were going to require you to develop what are called components, which we'll see a lot of later on. So the only point I'm trying to get across here now is that React was just, it didn't follow the diktat at the time. It made many design decisions which set it apart. And as things transpired, it seems that their design decisions were kind of well-founded, because a lot of single page app frameworks today, they also follow this component approach. Some of them still follow MVC, admittedly. Now, the table here kind of just compares and contrasts the two, and admittedly, you'd have to have some experience of playing around with React components to be able to appreciate this table. So I'm not going to dwell on it too much, but all the table is kind of telling us is if we try and compare the templating approach to the React component approach under 3 categories: separation of concerns, semantics, and expressiveness, then arguably React kind of wins on all 3. By separation of concerns, you've probably heard of this separation of concerns design objective, and with templating you did get separation of concerns, okay, but it was almost kind of in terms of at the physical file level. You had HTML files and JavaScript files, so there was separation there, but it was somewhat artificial, or so the React people argued, the React designers argued. Whereas when you're developing React components, each component has a single concern or a single responsibility. And so it achieves separation of concerns kind of at the functionality level rather than at the physical file level. And it's the functionality is what's important really in software development. In terms of semantics, with React, what you're writing is HTML and JavaScript, which, as we know, are 2 foundation technologies of the web. So React didn't introduce any new kind of syntax to us. Whereas templating, when you're using templating, typically there is a new syntax that you just have to become familiar with. And so it's a slight barrier, I guess. On the last category, expressiveness, well, because you're just using JavaScript with React components, and JavaScript is a very expressive language, as opposed to templating where you're using this, whatever templating syntax is being proposed by the templating technology, it's typically not as expressive as a fully fledged language like JavaScript. All right, let's not dwell on that too much, really. So point number 1 is that when you are developing React code, what you are building are components as opposed to constructing templates. And secondly, I've said that React is really all about the V part of MVC. So it's all about developing a user interface. It's not concerned with the M part or the C part of MVC. The M part in particular is still very important, but you would tend to use a separate library or framework in conjunction with React to code up the M part of your React application. So back to component. A component is made up of 2 parts. So we know now that a component is really about the user interface, and there's 2 parts to your user interface. Number 1, the actual just the layout of the interface, which I'm calling the UI description there. And secondly, it's behavior. The behavior is what happens when the user interacts with the user interface. How does it behave? Now, because React is in the web world, in terms of UI description, we still use HTML because that's foundational to the web. And in terms of UI behavior, we use JavaScript. But the thing is that a component is comprised of those 2 parts, the UI description and the UI behavior. And those 2 parts are physically located in the same file. They are co-located. Prior to React, they were in separate files. And arguably, there are some benefits to this component approach versus the templating approach, which I'm just listing there. It's easier to compose components than it is to compose templates. You get greater reusability from your component approach. Now, the last one there on the list, the performance, is not really due to components. That's due to another design decision that the React team made, which I'll talk about later on. It's something called the virtual DOM. So it's all a bit abstract so far, but that's okay. Now, I just want to change tack for a minute, if you like, and I want to go back to the website. We go into this week's section, and I want you to just click on the archive on the right there, and that will download a zip file. Then just locate the zip file. So in my case, it's going to be in here. Here's the zip file that will download, and when you unzip it, you will see this folder here. Now, if you start up VS Code, now I appreciate that maybe some people haven't used VS Code before. We'll just use it for this lecture, but after that, really, it's kind of optional as to whether you want to continue using it or not. And I want to import the archive that I've just downloaded into VS Code. So I'll just grab the folder and pull it across. And you can see that it has a package.json, so it is actually a little node project, if you like. We've got a few HTML files, and we've got some JavaScript files as well. Just in terms of the layout of VS Code, so this is what we call the sidebar menu, or sidebar over here. Here's the editor area. So once we look at a file, it appears over here. Then down at the bottom, we have what's called the panels area. One panel of particular interest is the terminal one. There's also an output one. But if you click on the terminal one, what it does is it starts up a terminal or command prompt or shell window, whatever you want to call it. And it positions the terminal in the folder that you're currently looking at. So this is my terminal area anyway, and I can submit terminal commands or DOS commands, or whatever you want to call them. So for example, one thing that you will need to do is run npm install from here. I've already done it now, but because you can see the node modules folder already exists up here. So as I said, you would just go npm and hit return, and it does its thing. Now, on the left here is what VS Code calls the activity area, and there are a number of links that you can click on to, depending on what activity you're currently involved in, if you like. The top one is the kind of source activity. So that's the one you click on when you're actually doing some development. The last one here is called the extensions activity. VS Code comes with a number of plugins or extensions that you can add on to your installation. And there is one that I just would like you to install for the purposes of this lecture. We will use it on one other occasion as well in a later lecture. But if you click on the extensions activity, and the extension I want you to install is called Live Server. There we go. There's Live Server, which I've already installed. Now, to install an extension, you just simply type in the name or part of the name of the extension, and VS Code will do a kind of a lookup in its remote repository, extension repository for you. So, you would type live in this case, and it finds any kind of matching extensions, and there are lots of them, as you can see. And beside each one, there will be an install button, and you just click on the install button to install that one. Now, in my case, because I've already installed Live Server, there is no button, but there would be in your case, and you just click the install button beside live server and let VS Code do its thing. You may need to restart VS Code after you've added an extension. So what live server is a little web server that you can run from within VS Code, which we will be doing in a moment now, because we will start up our web server and we're going to look at these HTML files to see what do they actually display on the screen for me. Okay, so let's just leave that there for now, I think, and let's go back. Well, just before I go back to the slides, when you have live server installed, and provided there is a HTML file somewhere in the base folder of the project that you're currently working on, what you will see down at the bottom, down here at the bottom, it may not be the extreme right now, but it'll be somewhere along here at the bottom, is a link labeled Go Live. Go Live. And if you click on that link, it starts up the web server for you, and it actually opens up a browser tab, and it switches over to the browser, and it will show you the contents of the folder that you're currently working on. Maybe we could just do that. And so what you can see here now is the contents of the folder that I've currently opened in VS Code. So React allows us to develop components. We'll come back to components in a while, but a component is made up of a UI description and a UI behavior. So let's take a look at the UI description. How do we code UI descriptions in React? Let's say that's our next objective. And the React framework is broken up into a number of packages or modules. And if I might just flick back to VS Code, if we look at the package.json associated with the little mini project that we're working on, we can see here that it just has two dependencies, two packages, one called React and one called React DOM. So these are two parts of these are two packages within the React framework. There are a couple of other ones, although I think these are the only two that we actually will ever need to use in this module. So either way, the React framework is broken up into a number of modules or packages. And the React package provides a method called createElement. And if you invoke that method, you are able to programmatically construct a HTML element, like a div or a button and so forth. The React DOM package, the second one, it provides a method called render. And what that will do is it will attach a HTML element to the browser's DOM. You remember now that the DOM is this data structure that the browser constructs when it receives some HTML. When you send a HTML page down to a browser, it takes that HTML, it analyzes it, it constructs a JavaScript object representation of that HTML, which is what we call the DOM. Now, in addition, if you programmatically change the DOM within the browser, any changes that you make to it, the browser will react to that change by reflecting the changes in what it actually displays on the screen. Okay, that's how browsers work. So what we want to do is we want to use these two methods to effectively programmatically construct a web page, a static web page. Admittedly, there won't be any behavior. That will come later on. So the createElement method, if we just look at its signature, it requires 3 arguments. The first argument, you tell it what type of element you want to create, what type of HTML element, a div or a button or a paragraph. The second argument is where you can associate what it calls properties with that element. like maybe if you want to associate some CSS class styles to it, or if you want to attach some sort of event handler. And the third argument is any children that you want to have associated with the element. As we know, if you have written any raw HTML, we nest elements inside other elements. So for example, you might have a div, and inside the div, there might be a paragraph followed by a button, followed by maybe another div. So we can nest elements in HTML. Well, the create element method allows us to actually code that nesting as well, as we'll see in a moment. So let's create element. It's something that's used extensively by React, but as it turns out, we don't have to code it directly ourselves. If we did have to, then it wouldn't really be a very pleasant experience. This is where actually JSX comes in, which we'll talk about in a while. But for now, let's see how we can actually use it directly ourselves. The second method that I mentioned then is the render method, which is associated with the React DOM package. And what that allows you to do is to programmatically attach a new element to the DOM. And as I said a moment ago, if you change the DOM at all, then the browser will reflect that change in what it displays on the screen. So the React DOM.render method allows us to attach an element, a HTML element, to the DOM, and so now the browser will actually display that element as a result. So if we look at the 01 file in the archive that we've just downloaded, we can see how these two methods can be used to programmatically construct a HTML file, or sorry, to programmatically construct a UI description. And so the file that we're interested in is, for now anyway, is this one. And before we look at the actual raw code, let's see what it actually, how it's actually reflected in the browser. So if I go back to, is my server running? It is, yeah. So if I go back to here, and if I click on 01, then that's what it displays. So let's see how that was generated. So this is an ordinary HTML file. As we can see, it has a header part, it has a body, the body has a div, it has an ID of that, that's okay. I'm kind of pulling in the two React packages, the React and React DOM, and then I've got some actual JavaScript code. And let's step through this a little bit. So here we go. We are actually using the React.createElement method to construct in this case, a H1 element. And I'm associating a CSS class called heading with that element. This CSS class actually comes from here. Okay, it's not terribly relevant, but that's where it comes from anyway. And okay, that's the effect of that. Don't worry about the fact that I'm using class name here instead of class. Talk about that some other time. And the label, or the piece of text that I want to attach to the H1 element, is languages. So I want that to be the text of the header. So that creates a H1 element for me. It doesn't display it on the screen though. I'm just constructing it programmatically. Then I go along and I create, it looks like 3 LI elements. Then I create a UL element. And if we look across here, so we're creating a UL element. We don't want any properties associated with it. And we want that element to have 3 children. And the 3 children are my LI elements that I've created here. And that kind of makes sense. The UL element as its children would have LI elements. I'm now creating a div element, and as its children, it has as its children the header that I created at the start and the UL element. Okay, so it has two children. That's all well and good. So my div has a H1 element and a UL element, and the UL element has as children 3 LI elements. So I've created that structure, and finally what I'm doing on this line is I'm attaching that little mini structure to the DOM. And so if you look again, so if you look quickly down through this now, I've got a header with the label languages, and I've got 3 LI elements, JavaScript, Java, Python as their text. And lo and behold, that is actually what is being displayed in the browser. So the code has programmatically constructed the web page at runtime. By at runtime, I mean once this overall file is sent to the browser, this JavaScript code executes, and the net effect is the browser displays what we have just shown. Okay, so that looks good. Back to my slides. It's not a very pleasant coding style though, and so that's why we don't actually use this style in real React development, but let's live with it for now. If we look at the 02 file, see what it does. It's actually very similar to 01 in terms of what it produces. So yeah, let's go back here. And if I click on 02, yeah, it looks like it's generating the exact same type of UI description. Let's see the code that produced it. I'm going to leave that open because I'd like to come back to that. Here's 02. Now, the only difference between 02 and 01 is I'm nesting invocations of React.createElement. I'm nesting the invocations. So what do I mean by that? Well, if I go back to 01, and for example, instead of actually kind of declaring a variable here called header and assigning it this expression, I could just take this expression and substitute it down here and just get rid of the variable. In other words, get rid of that there. Take what I'm assigning to it, which is all of this, and paste it down below. And that means now I can really just get rid of that variable declaration. Don't need that anymore. Now, that shouldn't really change anything in terms of what this code produces. Let's prove that. Let's look at 01 again. Yeah, so it still works. By the way, anytime I make a change to any of my files, the live server will reload that file in the browser for me. So that's just live reloading, which I'm sure you've come across before. So take it from me now that what I'm looking at here is what is actually produced by the current contents of my 01 UI description.html file. And I could continue on with that process of just essentially kind of getting rid of all of these variables and just replacing them. So instead of list, I could substitute in this code here and just keep on going. And if I keep on going, what I finish up with is essentially this, right? So let's just prove that. Yeah, so create element, and I've nested lots of invocations of create element within that. Done all of that, and then of course I always need to do this bit though. I always need to do the React DOM.render. Okay, so there isn't a whole lot of difference between 0.1 and 0.2. 0.2 is just slightly less coding, although it's probably slightly harder to follow the code initially anyway. And just to prove to you the importance of the React DOM.render, if we just take this file here, right? So let's display 0.2 in the browser. Make sure it's still working. So click on 0.2. Right, and if I go back to the file and let's make a change to it. Supposing I comment out this line. Now I've commented out, and because I've made a change to the file, the live server extension will spot that, and it will refresh the browser. And if I go back to the browser, suddenly nothing is being displayed. So that to me proves that it's not until I call React DOM.render that all of this kind of DOM elements that I'm creating here, they won't actually be displayed in the browser until I attach them to the current DOM. Okay, did I explain the React DOM.render? Oh yeah, the React DOM.render. So I'm telling it attach this element to the DOM, and the second argument here is telling it where to attach the element to the DOM. And so what this is really saying is find an element on the DOM that currently exists where that element has an ID of mount point. And if you look up here at the very top, you can see that I have a div already in my HTML page that has an ID of mount point. So I think I might have skipped that. That's really important. So the render method, you tell it what element you want to attach to DOM, and the second argument of render is telling it where on the DOM you want to attach that. Okay, let's leave that there. Now, if we had to write React code in the way that I've been doing it there, it wouldn't be a runner really. And this is where JSX comes into the picture. So JSX allows us to write UI descriptions in a more declarative way. The way I've been doing it up to now could be described as more an imperative or procedural approach towards coding. And JSX allows us to be more declarative in our coding style. And we'll see that in a moment. And what JSX then means is that your UI description can really utilize the full power of JavaScript. And it allows us to tightly couple the UI behavior with the UI description. You see, as we'll see, JSX is really going to be very, very close to HTML. So it effectively kind of allows us to mix HTML into our JavaScript code. And so the HTML or JSX really will be the UI description, and the rest of the JavaScript code will be the UI behavior, and they will be co-located or coupled together. Although our React little pages are static up to now, but we'll see that in a moment. Now, this JSX syntax, which is very HTML-like, as we'll see, that still has to be converted back, though, into ordinary JavaScript or vanilla JavaScript. In other words, it has to be converted back to the type of JavaScript that you've seen so far. You cannot send JSX syntax down to a browser. It doesn't know how to interpret it. But this conversion of JSX back to JavaScript, again, we don't really have to worry about that. There are tools to do it, and you've probably heard of the tool already. It's called Babel or Babel. And so Babel will convert all our JSX back to the kind of JavaScript that we've seen so far. It'll do that for us, so we don't have to worry about it. So the net effect is that we can write UI description code using this HTML-like syntax called JSX instead of writing it the way that we've been doing it up to now. And so to illustrate that, I have two files, 03 and 04. Now, just to prove this thing that the browser doesn't really understand this JSX syntax. So if we look at 03, so again, it's a HTML file, and here's my JavaScript code. But if you look at what I'm doing here, right, I'm declaring a variable, but I'm actually assigning a piece of HTML, or what looks very like HTML. It's 99% HTML. I'm assigning that piece of HTML snippet to a variable. That looks very odd, but that's actually perfectly acceptable in React. And then I'm doing as I did before. I'm attaching the element to the DOM as I did before. Now, the problem though is if I send this actual file down to the browser, it's going to complain because it does not understand how you can, it doesn't understand this as being proper JavaScript, which of course it isn't. This is technically now, this piece of code here is this JSX syntax that we've just mentioned. And so let's just see the browser not accepting this file. So if I click on 03, nothing happens. And if I open up the developer tools in Chrome, and if I look at, you can see here, it's giving me an error. And effectively, if you look at the error, it's complaining about this symbol in the JavaScript code that it's trying to execute. And of course, that symbol, which is on line 15, I think, that corresponds to line 15. It says, I don't understand this symbol here. This is not proper JavaScript, which of course it isn't. So what needs to happen is we need to transpile or convert this JSX back into ordinary JavaScript. In other words, convert it back to the type of code that we saw in the 01 and 02 files. So how do we do that? Well, we can do it manually. By manually, I mean, for example, if you go to this website, the babel.js.io, and if you click on try it out, what this allows you to do is to put JSX code here, and it will convert it into ordinary JavaScript over here. So let's just do that. So if I grab this piece of code, paste it in here. And here's the equivalent in what I call vanilla JavaScript. And if you look closely at it, you see that, you know, it's using React.createElement in the way that we were earlier on. And so what you would do then is you would just take this code, and that's the code that you need to substitute in here. Now, of course, that kind of manual transpilation process doesn't really scale, but so what I've done instead is I have created 04, and 04 now is just referring to a local JavaScript file, and the JavaScript file that it's referring to is up here. So I have two 04s, 04 pre and post transpiled. Okay, I've just given them kind of descriptive names. The 04 pre transpiled one is that. Okay, so that's the code that we want to have transpiled. And the transpiled version of it is that. Okay, this essentially, I essentially just cut and pasted that code from what appears here on the right, copied it into the file. And now if I try to load, sorry, 04, let's go back to the HTML. So it's referring to the 04 post transpiled JavaScript file. And so that should now work for me, I think. If I go back and see, does 04 work? Close down the developer tools maybe. Yeah, so 04 works. Okay, so we're getting very slowly closer to really where we want to be, which is writing our UI descriptions using this JSX syntax and writing the UI behavior, which we haven't looked at so far, just using ordinary JavaScript. So that's our first look at this thing called JSX. And that's just a reference to the website that can, okay, it's kind of useful if you're just initially when you're just learning about this, but we won't be using it really after today, to be quite honest. So JSX is this HTML-like syntax, and really, as I said, it's kind of 99% HTML, although technically it's what's called XML. One of the few differences between HTML and JSX is, you know, in HTML, if you want to associate a CSS class with a HTML element, then you use the class attribute. Now, class is a reserved word in JavaScript, so we can't use that. And so instead, we use the label class name. And so if I go back to a little bit of JSX that we've seen so far, if you see here, I want to associate this CSS class with my H1, and I'm using the attribute class name here instead of class. And really, that I think is the only difference between JSX and HTML that you will come across. And so that's what's really nice about JSX. It really allows us to write HTML and embed that HTML syntax in our JavaScript files. So it allows the UI description to be co-located with our UI behavior, as I've said a number of times already. And it is a more kind of declarative style rather than a procedural style. JSX allows us to code our UI descriptions in a declarative style. The transpilation, well, by what I mean there, what do we use to perform the transpilation of JSX back to vanilla JavaScript? As I've already said, it's the Babel tool. Now, there are a number of ways that you can do this in terms of how you do the transpilation. You can do it manually using the REPL or using that little website that I've mentioned. There is also a command line tool that you can use to transpile individual files. Neither of those approaches are really scalable, so you would only use them as a very kind of beginner. The second way, which we will do quite a lot, is you can get special web servers that are instrumented with the Babel transpilers, and they will carry out the transpilation for you. So you effectively get this kind of experience where, as you're developing your React application, whenever you make a change to a file and you save that file, the web server will pick up the change and it will carry out the transpilation process automatically, and it will update the browser with the changes that you've made. It's this kind of live reloading experience, which I'm sure you've come across already in the context of enterprise web. So that's number two. The third thing, eventually, these specially instrumented web servers, they're great when you're doing development, but when you want to actually deploy your React app in a production environment, you can't really have this kind of live reloading and live retranspilation going on in the background. What you then need to do is you need to use kind of a build tool, and these build tools exist, and what they do is they just essentially kind of gobble up all of the files that make up your React application, carry out transpilation on all of them, and wrap them up in a nice minified JavaScript file for you. And we'll see that in action later on as well. So 2 and 3 we use a lot. We never use number 1 in that list. Now, I began by saying that when you develop a React application, you develop components, but we haven't seen a component so far. So where does that fit in the picture? Now, in terms of coding a React component, it is simply going to be a JavaScript function. So a React component is a JavaScript function, and you can have any kind of logic you want to in that function, but critically, the function has to return the UI description associated with that component. So it has to return a snippet of JSX code. And so the body of the function would be where you encode the behavior that you want to have associated with the component, and the return statement will contain the UI description for the component. And when we write these components, effectively kind of what we're doing is we're extending HTML, the HTML syntax. We're kind of defining new tags for ourselves. You can think of it in that way. And so what we will see is when we use the React DOM.render, we can actually specify a component using the kind of angle brackets as if the component was a valid HTML element. And so our first example of a component is sample 05. So let's have a look at that. Now, of course, there is a pre-transpiled and post-transpiled aspect going on here again. So the HTML file, there's nothing terribly interesting there. It's just referring to this other JavaScript file, which is up here. And just for the purpose of illustration, I have two versions of 05 JavaScript. I have the pre-transpiled version and the post-transpiled version, or the source version and the transpiled version. And it's the source version that we write. We write the source, and Babel will create the transpiled version of that for us. So in terms of understanding the code, we really only need to look at the source representation of our component. So here's our very first example of a React component. And as I said on the slide, a React component is a function. And you can see here, I'm using the JavaScript arrow syntax for defining my function. You can use the old style function declaration if you want to, but any articles that you read about JavaScript, we use the arrow representation. So this function doesn't take any arguments for now anyway. And the body of the function doesn't have any real logic in it, although you could. So you can put any kind of logic in here that you want to. And as I said, it returns, the function must return a JSX syntax snippet, and that's what it's doing here. Here's the kind of JSX that we've seen already. By the way, if your JSX is multi-line, which it is in this case, you do have to wrap it in parentheses. Don't think I mentioned that earlier on. So, and again, we can kind of, we can pass this, or this has to be transpiled, and by now, you know, we don't really need to worry about the transpilation. You could cut and paste this into the Babel website that I showed you there a while ago, and you could see the transpiled version. In fact, you know, this is the transpiled version of that. And surprise, surprise, you know, create element is scattered all over the place in it. So as React developers, what we write is this, and Babel will do the rest for us in terms of converting it into something that's executable by the browser. So does 0.5, I think it produces pretty much the same type of result. Yeah, something similar. So that's a component, or our very, very first look at a component. Now, in terms of tools that are available to us for doing React development, there are two really important ones, and they're the two that are used most in industry, and they're the two that we were using throughout this module. The first tool is called Create React App, and as its name suggests, it's a tool for developing a full React application. And it does the kind of things that you've probably seen already in Enterprise Web. When you use this tool, you can get it to construct a folder structure or do some scaffolding for you. It comes with its own development web server that is fully wired up with the Babel transpilation that's necessary. The web server performs live reloading for us. So as we're doing our development and making changes to files, those changes will be reflected in the app as it's being displayed in the browser. So we get that kind of instant response to any modifications that we make to our code. We can see what's happening in the browser. And thirdly, it provides tools that allow us to create a deployable version of our React application that we can deploy to a cloud platform. That's Create React App. The second tool is a tool called Storybook. And whereas Create React App is what you use when you're developing a complete application, Storybook is really great when you're developing individual components. And of course, you know, when you're building an app is made up of components. So typically you would develop some components first and then start gluing them together. So Storybook is great as a development tool for individual components. So as I'm saying here, it's a development environment for developing components in isolation. So we don't have to worry about all of the paraphernalia around an entire app. We just want to develop a single component. And critically, we want to see how does that component render in the browser. And the Storybook will facilitate us with that. And arguably, if you can develop components in isolation, then you tend to make those components reusable. It's kind of a byproduct of developing components in isolation. And also the components are more testable, although we won't get into testing individual components. And your development experience is also much quicker. It's kind of encouraging when you find yourself getting components working before you start thinking about the bigger picture of an entire app. So I just want to talk a little bit about Storybook for a while. It comes in the form of an NPM package, so you install it in the usual way. And the tool itself is made up of two parts. There's a server, a web server, which you start from the command line, and that performs live retranslation and live reloading. So as you're modifying your components, it will pick up the modification and do a retranslation and send the updates down to the browser. And it also has its own web-based user interface, which will allow you to see how your components are rendering as you develop them. What you see here is what Storybook's user interface looks like. So on the left, it will show a list of the components in the project that you're working on. And those component names will be clickable. And as you click on them, it will show you on the right how the component is rendering. And so really with Storybook, that's what you're trying to achieve. You're trying to make sure that your individual components are rendering or displaying properly. And once they are, then you can start tackling the bigger problem of putting them together into an app and adding some functionality and dynamics to the app. Now, where did this name Storybook comes from, or what is the story in the context of components? So if you think about it, a component may have different renderings. It may render slightly different depending on the data that it's trying to render. And so what we say is that a component may have several states, and the state affects how it renders. And so each state is what is referred to as a story. And so when you're designing a component, part of the design process is to identify what are the different possible states that this component might have, and how do I want the component to render for each of those states or stories. Now, in many cases, to be honest, a component may only have one state, but you have the ability to add many states depending on the sophistication, I suppose, of the component itself. So just by way of example, the component that we've looked at there just a few moments ago, it displayed a list of programming languages. So let's supposing I write a component that just displays a list of dynamic programming languages. And let's assume that the list of languages that it wants to display are passed into it somehow. We'll see later on how you can actually pass parameters or properties into a component, but we'll just take it as read for now that you can pass an array of programming language names into this component of mine. But the way I want the component to render that list is going to be slightly different depending on how many entries are in the array. This is just a design decision that I've made for myself. And let's supposing I've decided that if the array contains 5 or less languages, then the component will just render them as a list. If it receives an array with no entries, then rather than displaying nothing, it's just going to display a message saying no languages. Just slightly better slightly better user experience, I suppose. And thirdly, if the array is larger than 5, then I want the component just to list the first 5, but also have a little more button, so that when the user clicks on that, the component will list the next 5, and it'll keep on going through the array in that way. Okay, so they are my 3 states or my 3 stories for my component. And I've given the 3 stories nice kind of meaningful names: default, boundary, and exceptional. Now, in terms of how I'd like that to appear in Storybook's UI interface, you can see on the left there now that underneath a component, you can actually have the different states or stories for that component. And by clicking on each of the stories, it'll display on the right how the component will render for that particular story. We have to write these stories, of course, which I'll come on to in a second, but again, from a design point of view, that's what I'm trying to achieve. And because my component has a number of states, I would like the Storybook UI to illustrate that as it is there in that screenshot. If you've got a large number of components in a project, then rather than listing them kind of linearly on the left, it might be useful, especially to other members of your project team, to group the components in some sort of logical way. And equally, we would like Storybook to reflect that grouping in how it lists the components on the left-hand side there. So I've just come up with some arbitrary names, but you would have more meaningful names. Obviously, I've got a group A, and it has, it looks like 3 components in it, and I've got a group B. But it's just the way that we would like Storybook to make the grouping or the categorization fairly obvious in the way it lists the components. So to use Storybook, though, you have to write these stories or implement the stories. And you implement them as JavaScript, although the style of the JavaScript might be slightly complicated looking, but it's not really actually once you get the swing of it. So this is an excerpt from the stories implementation that I have for my fictitious dynamic languages component that I've been talking about. And so if we just kind of, now I've removed some of the detail because we're not interested in the heavy detail. We're just interested in the outline of how you implement these stories. So you can see here, I'm importing the Storybook, part of the Storybook library or package that I've downloaded. And in particular, I'm importing a function called stories of. And down here, I'm using the stories of function. And so you pass the stories of function a string, but typically the string might be the name of the component that the stories are related to. It doesn't have to be an exact match of the component name. It could be a slightly more descriptive thing because it is a string after all. But for now, let's just say it's the component name in string form. And then you chain on invocations of the add method for every story associated with that component. Okay, so the programming style here is often referred to as a method chaining style, which you may have used before. So this is the approach that the Storybook designers decided to implement the stories API, if you like. Okay, so you invoke this, you chain on an invocation of the add method for each story. The add method takes 2 arguments. The first argument is typically the name of the story or some sort of label for it. The second argument is an arrow function or any kind of form of JavaScript function. Now this function, it can have any logic you want in it. It doesn't tend to have a whole lot though, other than maybe declaring some data that you want to pass into the component. But critically, the arrow function must return an instance of the component that the story relates to. And so what I'm doing here is I'm returning an instance of my dynamic languages component, which of course I'm importing at the top up here. And for now, you can just interpret what's going on over here as being, I'm passing in a parameter into my dynamic languages component. The parameter is called list, and it's actually the array that I've declared up here. I'll come back to this later on in this lecture, how you actually pass parameters and how they're accessed within the component. So that is one story, and then you implement the other stories in this kind of chained method invocation style. Right? It might be slightly confusing looking initially because this idea of having a function as an argument to a method. Okay, we often refer to the function as a callback function. So that's how you, that's an outline of how you implement your stories. And of course, it's the implementation of the stories that's what controls what is displayed over here. Well, let's say use this example. That's how the Storybook server determines what it should show here on the right-hand side. Okay, what's next? Oh yeah, if you do want to group your components and you want that grouping to be reflected in how Storybook lists the components on the left-hand side of its UI, then what you do is, you can see by way of an example here, I've decided that I'm going to have a group called Group A and Group B. And so in the stories of function, the string that I'm passing into it contains the group name followed by a slash. Now the slash is very important because the Storybook actually uses that to determine that the first part is a group name and the second part is the component name. And you can see as well that typically within your stories implementation, you can actually call the stories of function many times within the one file. Yeah. So that's how you indicate to Storybook the fact that your components are gathered into groups. Let's go back to components though, because that's really what we want to be able to implement. But you will be writing your stories as well in parallel with the implementation of your components. Now, what I'm showing you here is really the basis for the first lab in this week's lecture. In the very first lab, you will download another zip file and unzip it. And it's another node project. And what it has is implementations of some sample components, which I will talk my way through for the remainder of this lecture. So you can see on the right there is a components folder, and it has two subfolders called exercises and samples. In the samples folder, there are a number of components illustrating various aspects of the JSX kind of syntax and components in general. And above that, there's an exercises folder, and in there I have put empty or stub implementations of, I think it's about 4 or 5 components. And the objective of the lab exercise is that you complete the implementation of those components based on the requirements that I specify in the lab. Further down, you'll see there is a folder called Stories, and I've decided to break it up into 2 subfiles. So both of these files contains implementations of stories, and as you can tell from the name, the samples.stories.js contain implementations of the stories associated with the sample components, and the exercises file contains implementations of stories for the exercise components that you will develop. So I've actually provided you with the implementation of the stories for the exercise components that you develop, but it would be worthwhile just to look at the story implementation so that you get familiar with writing story code, because that will be part of the assignment down the line. On the top there, I have a folder called .storybook. It contains some basic configuration information that the Storybook server uses to work out, well, where are the actual stories implemented. So it will tell us that the stories are down here. And in the stories, then it will actually read through the story implementations. And of course, the import statements at the top of the story implementations will refer to where the actual components exist. So essentially, when you start up the Storybook server, it goes to the configuration folder that tells it where to find the stories. The story implementations tells us where to find the components, and it essentially consumes all of that code. It reads through all of that code, transpiles it, kicks off a browser tab and fills out the UI, the Storybook UI, based on what it has read in terms of the stories and the components. On the left, I'm showing you what the Storybook UI will look like initially. Okay. So, and as I said, you'll find that at the very beginning of the first lab. In fact, I'm just going to flip over. So when you download this archive from the first lab and unzip it, you get this folder here. And if I copy that over into VS Code, I'm just going to dig into the configuration. Really, the configuration stuff is boilerplate. You rarely need to change it. And there are some conventions. There typically are two files, one called config and the other called add-ons. I think my add-on is empty for now. The config has very little in it. And really all this line of code is telling the Storybook server is telling it to go look in a subfolder called stories, which of course is down here. And it's telling us to pick up any file with the extension .stories.js, and that's where the stories are implemented. And as I said, there they exist. There's no real requirement to have .stories.js as the file extension for your story implementations. I think most people just use .js, but either way, as long as you tell Storybook what the file extension is and where to find them, then it can take care of the rest. And if I just look at the package.json maybe as well before in my package.json, I've got a script here. I don't think I mentioned it when I introduced Storybook, but this is how you start the Storybook server, okay? And I've just, rather than typing this long command on the command line, I've just made a script for it. So this is, you need to tell Storybook what port it should use in the browser tab, or what port it should use as its web server port. And you've got to tell it where is the configuration for your stories. Okay, that's what I'm doing here. So if I start up my Storybook server as follows. Now when I hit return, as I said, it's going to go to the configuration files. That's going to tell it where the stories are implemented. It's going to read the story implementation files. It's going to transpile all of that code. As part of the transpilation, it's then going to pick up the actual component implementations, transpile all of that code, send the whole lot down to the browser, and as well send Storybook's own user interface code down to the browser. And so when I hit return, so it's going away processing and transpiling all of the code, and eventually it'll kick over to the browser, and voila, I have my components, or I have my user interface. And if I look at the samples, these are the various samples that I'll talk through in a while. You can see the exercise components are all to-dos. So that would be the first lab. Now, the whole point of this, though, is to allow me to talk about components and some basic aspects of component implementation. The first thing I want to talk about is the component that we've had so far. It's completely static. There's no variable part in it at all. One thing that we would like to be able to do is embed variables within our JSX code. And if you want to do that, all you've got to do is wrap the variable reference in curly braces. So when JSX contains curly braces, whatever is inside the curly braces at runtime, that will be evaluated, and the result of the evaluation will be added to the JSX code. So if you look at the sample that I have down here, so I've declared, this is a component that I've just called demo, and I'm declaring two variables. One is an array of languages, and that one is just an ordinary string. And here's my component return statement, returning its JSX. But if you look at the LI elements within the JSX, I'm actually dereferencing entries in my languages array from up here. Yeah. Now, but of course, critically, I'm wrapping the reference in the curly braces. So that tells React to evaluate what's inside the curly braces first before it actually decides what to display on the screen. Up here, I'm doing something slightly more advanced. It turns out that you can have any kind of JavaScript expression inside the curly braces. So up here, what I'm actually doing is I'm constructing a string using string templating. You're familiar with string templating. It's just a feature of the JavaScript language itself. So I'm constructing a string here. So at runtime, the string will be, this entire string template will be computed, if you like, and the result of the computation will be displayed on the screen. Okay, so other things that you might do inside within the curly braces, you might call a function, and the return value of the function is what's displayed on the screen. So that's sample 02 in the sample that I've been talking about. So if I maybe flip over to the browser. And sample 2, that's how it renders. Let's look at the actual code associated with it. Okay, so it's as before. And for completeness now, let's look at the story. Story isn't too interesting, but so the stories for the samples are in the samples.stories.js. And yeah, here it is here. Sorry, no, here it is here. Okay, so it's pretty basic, really. Just as a by the way, it's not a React thing now, but it's just a JavaScript thing. If I go back to the story implementation, oh, sorry, the component implementation. So I've called the component demo, okay, and that's what I'm exporting. And when I look at the stories implementation, I'm importing the particular file here. Okay, I've also given a different name to the file. Now that wouldn't be normal, but it's just to make sure, to make it clear what each file contains. That's the file that contains the component, but I'm importing it and giving it a different name, and that's just valid. That's okay from a JavaScript point of view. As you saw in the file, I call the component demo, but here now I'm kind of renaming the component to something more meaningful. It would be normal, to be quite honest, it would be normal that in a component, we typically have one component per file, and typically the file name would match the component name, and the component name would, should be anyway, something more meaningful and indicative of what the component is about. Demo now would not be a good name, but I just took the, it was just a convenience that I called it demo. In fact, I call all my components demo in this project, but from here on in, you shouldn't do that. Okay, that's fine for now. So that's lesson number 1. How do you embed variables or any kind of JavaScript expression within your JSX? And the answer is just wrap it in curly braces. One of the first mistakes that you might make when you're doing React development is you might accidentally leave out the curly braces here. So all that's going to happen really is the component will display the literal string lang languages square bracket 0 square brackets. So it doesn't evaluate it at all. So that's the first one. The next thing, so far our component is completely insulated. We can't actually influence it from the outside at all, or to put it another way, our components are completely unreusable. And that's not a good state to be in. We would like to be able to pass properties or parameters into our components. We'd like to parameterize them. And we can do that. We refer to the parameters as props, or in the language of React, we talk about passing props into a component. And there are 2 things that we'd like to know. A, how do we pass parameters or props into a component? And number 2, how does the component access those parameters internally? So the way we pass properties in, it's a bit like really attributes of a HTML tag. So the illustration here shows that I want to pass in a prop or a parameter, which I've called this being list name, prop1, and I want to give it that value. Again, you've got to wrap the value in the curly braces because of the discussion that we had in the previous slide. And I've got a second prop, and it's got that value. The props that a component might need would be part of the whole design process for a component. So that's how we pass props or parameters into a component. There's essentially a set of key value pairs. Inside the component, then, how do you dereference those props? Now, as we know, a component is implemented as a function, and there is a default argument for that function. You can call the argument anything, but the convention is to call it props. So this props argument will be initialized with the values that are passed in up here. Props is going to be an object with a JavaScript object, and its keys will correspond to the property names that you've used up here. So you can see what I'm doing within my component here is I'm, as I said, props is an object, so I'm referencing the prop1 name key within that object. So that expression is going to evaluate to whatever value I had here. And I'm assigning the P1 and doing whatever with it. So this is how we dereference or access the properties within a component. That's the syntax for us. Down at the bottom here, I'm telling you a couple of characteristics of props. Number 1, they're immutable. You cannot modify the value of a prop that's passed in. Okay, that's a conscious decision made by the React designers. Number 2, I've already mentioned. Sorry, number 3 and 4. Oh yeah, sorry. Point 4 there, I've already mentioned that it's really part of when you're developing a component, one of the design decisions you have to make is what properties do I need to pass into it? How many properties, what types should they be, etc., etc. So our component is a little bit more reusable now because of this. And to illustrate it, we're looking at sample 03. So I'm sticking with the same kind of context, really, a component that lists or displays a list of things. Now, in order to kind of understand what this component is meant to do, I suppose we really need to look at the story associated with it. So let's do that. And again, another point is that I've used a kind of numbering system here just to make it a little bit easier for you to follow what's going on here. So the number 0, 1, 2, 3 kind of correspond to the component file names. Yeah. So we're looking at sample 03, and we are declaring an ordinary string here. Here we're invoking the component in question, which I've imported again at the very top. Here's where I've imported it. And I am passing in two properties, which I've called languages and heading. Again, you can choose the variable names yourself as part of the design. Languages is assigned list, and list is actually declared somewhere. Where is list declared? Oh yeah, there it is up here. So that's what I'm passing into my component, and the component then is expecting those properties. And here we go again. We're dereferencing the languages array, props.languages, subscript, etc., etc. Now, what's not great about this component is that it expects exactly 3 entries in the array. We'd like to be a little bit more flexible than that, and we'll come to how we do that in a while. But that demonstrates props here, and here's our props declaration, and the rest is self-explanatory, I hope. So that's how you parameterize components. Props are a really important aspect of component development. Now, before I discuss the next sample, I just want to remind you of 1 or 2 things about JavaScript, or maybe inform you, depending on whether you know about these things or not. So the first thing I suspect you may already know, with arrow functions in JavaScript, if the function only has 1 line of code in its body, and that is its return statement, then a lot of the syntax around the function, the arrow function declaration, can be dropped. So just by way of example, you can see here my arrow function. It has only 1 line of code in its body, and that is what it returns. And so because of that, I can actually rewrite this arrow function like this. Okay, I can drop the curly braces entirely, and I can drop the return keyword to give me all of that. Yeah. So you may already know that, I'd say, but I'm just refreshing that knowledge. You may not know about this. So the JavaScript array type comes with a built-in method called map. And what the map method does is it takes the source array that you're invoking the method on, and it produces an output array. And the output array is dictated by the first argument of the map method, which is going to be a callback function. And so essentially what it does is, for each element in the source array, it invokes the callback function, and whatever the return value of that callback function is, that's what it puts in the corresponding entry in the output array of map. Here's an example of that in action. So I've got an array of JavaScript objects, yeah, and here I'm invoking the map method on that array. And I'm passing in a function to the map method, which is what it expects. And as I said, what the map method does is it invokes this function for every entry in this array, one by one. So in my case, I want the function to, the arrow function expects 2 arguments. The first argument will be bound to the entry in the array that's currently being processed. The second argument is just going to be the index position of that array entry. So it's going to call this function for this entry. And so what the callback function does again is it's using string templating to construct a string. And the string that it constructs, it's going to put it into the output array. So my output array should have 3 entries in it because there are 3 entries in my source array. And if I did a console.log of the output array, then what you should see is what I've joined down here. So map maps over an array to produce an output array. And there's a 1-for-1 correspondence between the input array and the output array. The contents of the output array is determined by the function the callback function that you pass the map. Okay, because we actually use this technique a lot in React. The next thing is a React specific thing, and it is that you can assign a piece of JSX to a variable. Now, you can just take that, right? That you can do that. It has to be a single element, though. I could not here in this example. I could not assign demo to h1, h2. I have to wrap it in a div. And of course, this all works because of what I told you way back at the beginning of this lecture. This idea that the JSX is transpiled into invocations, nested invocations of React.create element. But it's probably not that useful to continuously reflect back on that fact. It's better just to accept JSX for what it is and get used to the declarative style that we're encouraged to use, rather than thinking about, well, how does this transpile, or what does this transpile back to? But for now, anyway, you can assign a single JSX element to a variable, even though that element might have nested elements within it. That's fine. So armed with all of that knowledge, we come on to the next example. And in the next example, what I'd like to be able to do is to iterate over an array of a data array, and for each entry in that data array, produce as output a JSX snippet, and then maybe display the array of JSX snippets that have been produced. Okay, so that's the use case: generate a collection of JSX elements based on, typically based on a prop, which is an array that has been passed into the component. That's really what we find ourselves doing a lot. So we're asked to look at sample 04. And what sample 04, the objective is, this is what we want the component to produce. We want it to produce a collection or an array of LI elements based on a data array that was passed into it. So let's look at sample 4. And I'm going to look at the story first before we look at the actual implementation. So here's the component, and I'm passing in, again, happens to be 2 arguments. The first one is this array here, which I have declared up on top. And it's like the actual sample that I had a while ago. So it's an array of objects. In this case, the objects happen to contain details about different single page app frameworks, it looks like, but it's just an array of objects. And I'm passing in a string as well. Okay, so what does the actual component do? And it's actually mapping over the array that has been passed into it. And for each entry in the array, my function is returning an li element. So this list array here now should contain an array of li elements. Yeah. And each li element has an embedded hyperlink, and the hyperlink contains, will display the name of the single page app framework and a link to that framework's documentation page, I guess. This bit here, the key, if you have an array of elements, well, sorry, just before I talk about that, sorry. If we look down then further, what my component is rendering is, it's just rendering the array. And I am wrapping the array in UL tags, which makes sense because this now is actually a collection of li elements, and we should wrap li elements within a UL container. But what React does encourage you, you're not forced to, but you're encouraged to make sure when you do have an array of elements, whatever type they are, that you want to have rendered by a component, you are encouraged to make sure that each entry in that array has a key attribute, and the value associated with the key attribute is unique. The value can be anything you want it to be, but make sure it's unique within the collection of array elements. Okay, and so that would, by using index here, which is the second argument of my callback function, the index is going to be 0, 1, 2, 3, etc. So I'm just assigning that value to this key attribute of my li element. Okay, it's not obvious why you need to do that. I can tell you it helps React runtime to work out when a collection of things actually change. It helps it to work out what does it need to update in the screen. But for now, just take it as a requirement that you should follow. Okay, and we can just see the component rendering, I suppose. So we're on to sample 4. That's not sample 4. There we go. And just to prove that, so what's nice now about this component is it's flexible, right? No matter how big or small the array is, my component will generate the correct number of li elements based on the data that's passed into it. And so, just to mess around with it, if I go back to the story and let's do this, right? Let's put 6 entries into the array. Given that my Storybook server is going to pick up the change that I've made and do live retranspilation, etc., etc. But if I flip back to the browser, then it has updated it. But the point I'm trying to get across here really is that my component now is quite flexible. I can give it any number of entries in the array, and the component will, at runtime, work out, or it will compute the list of things that it wants to render. So that enhances the idea of reusability, as well as being dynamic. Okay, and as I said, that is a technique that we use a lot, as you'll see going forward. Just to go off on a slight tangent, so a component, its return statement is a piece of JSX, but it has to be a single JSX element, even though that can have nested elements. So each of these return statements would be valid within a component. Okay, so sometimes, and quite a lot actually, components will be returning other components, hence this idea of composing components together. If a component returns a multi-line JSX, as we are here, then it has to wrap it in parentheses. I think I've mentioned this before. So they're all fine. What you need to remember is that the return statement has to be a single element. So the example here is not going to work. This won't work because we're not returning a single element. We're actually returning two elements. And so the browser is going to throw up an error when React tries to render this. You'll actually get a compile time error, actually possibly on the server side. So how do you solve this problem? If that's all I want my component to return, how do you solve it? Well, you just simply wrap it in a div, and that will solve it. This is the actual error that you get. You'll see the error in the developer console of the browser. So it's kind of a runtime thing, really. Now there was, so the old solution was to actually wrap it in a div. So as I said, React is around since 2013. And initially that was the solution. But of course, there were downsides. Well, not of course, but there were actually downsides to that. It meant that for very large React applications, you had an awful lot of nesting of divs, which were really unnecessary. The only reason we have to wrap our JSX there in a div is just because of this rule that React has, that a component can only return a single element. Of course, the rule again goes back to the discussion that we had at the beginning as to how all of this is transpiled, and it goes back to that React.create element. But the fact that we do have to wrap it in a div means that for very large React applications, the HTML that's kind of generated by your React application will be very deeply nested, and that actually can impact on the runtime performance of your React app in the browser. So to solve that problem, React actually gave us a special little tag that we can use, which you can see on the right there. So this here is kind of an opening tag and its corresponding closing tag. And they actually don't appear at all in the DOM. Sorry, when I was discussing this over here on the left, as already mentioned earlier on, all of this is constructed in the browser's DOM data structure. So the DOM data structure is going to have all of these nested divs, which are play no role other than to satisfy React. Well, if instead we use this special tag that the React framework gives us, all of those divs disappear. And so the DOM is just physically a slightly less deep data structure as a result. And that can make your React application in the browser a little bit more performant. Only really is significant for very large React applications, but it's a style or it's a technique that you should use, and I use it throughout this course. Back to components, and the last thing I want to illustrate is component hierarchy. Now, the statement here at this top is a big statement, but it's true, and it is that all React applications finish up as a hierarchy of components. Every React application has that characteristic. There is a component at the very top. It has children. Those child components have their own children, and so you've got this hierarchy or tree of components. You can't avoid that given the way we actually design React apps, as we'll see in future lectures. Just a simple illustration of that. We're on to sample 5. So it's kind of an artificial illustration of it. Do I have a screenshot of it? Oh yeah, this is what the component is going to render like. So in fact, I'm using 3 components. I have my component at the top, which I've just labeled there as 1, and it has 2 child components nested within it. Yeah. So if we look at the implementation of the component 1 there, it's going to look like this. So I'm actually reusing some of the earlier components from the earlier samples. So here's my component, and really all I'm kind of illustrating is that as part of the return statement of this component, it's actually using some other components from elsewhere in the project. Yeah, and I'm using 2 other components plus some ordinary HTML, if you like. So this component has 2 child components that it's leveraging. Okay, and is there props going on there? Yeah, so you can look at the story for that component yourselves later on. That's quite it's quite involved there now, so make sure you just take the time to study the flow of that syntax and that it makes sense to you. And that's it for lecture 1. So we've covered a lot of ground, really. We have some sense of this JSX syntax, which allows us to declaratively describe a component's user interface. None of our components have any behavior so far. That's going to change. We can embed any kind of variable or expression within our JSX. React is all about developing components, and a component is nothing other than a JavaScript function. You can pass data into that function in the form of props. And we use Storybook as a tool to help us ensure that a component renders correctly. So it's kind of over to you now to tackle the 2 labs. So the lab number 1 is what we have been talking through. Lab number 2 actually introduces you to the Create React App tool. I haven't talked about that really today, mainly because it's going to be very like the tools that you would have used with the Play framework and even the stuff that you were doing in Enterprise Web. And the Create React App tool is very much in the background. You don't have to do any configuring of it. It comes with its own server. You start up the server and it just renders your React app in the browser for you. Yeah. But we may talk about it later on, but I don't think there's a whole lot I need to talk my way through. It should be fairly easy for you to actually use it. Okay, so see how you get on, and I'll see you in lecture number 2.